Hello, welcome. Today let's try to solve Leetcode problem 94, binary tree in order traversal. Let me first go to the whiteboard. After that, I will go to the code editor to finish the coding. So this is a in order traversal. While we are trying to solve the in order traversal of the binary tree, so we're gonna first check the left node. So for example, this is the root. There's nothing from the left, so we're gonna first check the left. There's nothing, and then we check the mid node. So it is 1. We put a 1 inside our result. And then we're gonna check from the right. Yeah. So while we go to this right node, we will not put it inside our result. We're gonna first check the left. So it will be 3, and then it will be 2, because after left, we're gonna take the middle node. And then we're gonna check the right node. So there's nothing in the right node. So this is the result we just need to return. Yeah. So there are two solutions basically. So one is the recursive solution. It is a little bit easier. We can, because this way it's not only easy to remember, but also easy to understand. Yeah, because basically this is everything about recursive function is first left and then middle node and then right. Yeah. So we need to check if the node exists, and then we use the recursive function, go to the left, and then we put the value inside our result, and then we check the right side. Yeah. So let me first finish the recursive recursive solution. So we need to first check define a in order recursive function, and inside it's gonna be node and result. So finally, I'm going to return this result. Yeah, and I would like to call this in order function, and inside it's gonna be root and empty array. Now I'm going to define this in order function. So I will first check if the node exists or not. Yeah, so if the node exists, I can go for my recursive function to check first left and then mid and then right. If the node does not exist, I will not do anything and just return my result. Yeah, so for example, for the first one, if the node exists because the first one is the root node. So what I gonna do, I just need to check from the left side. So I can use in order node dot left. So this means this is 1 from the left, it is empty. Yeah, but even it is empty, I didn't do anything. Yeah, but when it comes to the mid node, I will take it inside my result. So the result should append node dot val, and then we're gonna traversal the node dot right. Yeah. So this means from the left there's nothing inside. Yeah, but we can take the node dot value because this is the mid value. So yeah, this recursive function is in order from node left. So it's nothing returned. We didn't do anything. But this result dot append node dot value. So it is 1. We put 1 inside the result, and then we go to in order node dot right. So we go from the node 2. Yeah, so from the node 2, we will do the recursive function again. So in order node dot left, so the left exists. Yeah, so if the left exists, we're gonna do this function node dot left first. Yeah, so we're gonna check this 3 first. So this 3 from the left side, there's nothing, and result should append the value of 3, and then go to the right. Right is nothing. After finishing this node dot left, we go to result dot append node dot value. So here node dot value is 2. We append this value 2. So this means 1, 3, and 2. Yeah. After all, we go to node dot right. So for the node 2 from the right, there's nothing. So we didn't do anything, just to return this result, because here is a if tag for the recursive function call. Now let me run it to check if this works. And by the way, the time complexity is just ON. Yeah, I need to put another variable inside because the recursive function is about 2 variables. So one is the node left, another is the result. Now let me run it to check if it works. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. Now as you can see, it works and it's pretty fast. Now let's try to solve it in another way by using stack. So basically stack is an iterative function, and this is a little bit harder, but the principle is similar. Yeah, because it is still the in-order traversal. What is in-order traversal? In-order traversal is about we're gonna first check the left side and then mid and then from the right side of the node. Yeah, but if we were to easily understand the process of the stack, actually the stack is to understand why we're gonna use the iterative solution like that. So we're gonna first check the left side of the node. So for each tree node, we're gonna prepare the left side first. So for example, this tree node from here, we're gonna check this left side first. Yeah, we're gonna always check like this. But while we are doing the stack, so for example, we have a node 1 and node 2. So those nodes should put inside the stack. So what is the sequence? Put it inside the stack. We should always put 2 inside. Yeah, we should always put node 1 inside. Then we can put node 2. Yeah, why? Because we need to take out this 2 first as our result, and then we will take node 1. Yeah, so this means from the stack, we're gonna always take the first one first. Yeah, so this is the left side. We're gonna always check the left side of like this because we wanna always put the left side structure, yeah, like this line and this line inside of the stack, and then we're gonna pop it out. But what is the sequence? It's gonna be always be 1 and 2. So for example, 1 and 2 inside of the stack. So this is the sequence because in this way, we're gonna pop out 2 first. So 2 will be inside the result, and then we're gonna pop out 1. So the result will be 2 and 1 for this example. So if there are like 3 and 4 and others, it will be the same. We just need to put the 3 inside the stack, and then we're gonna pop out 1 by 1. So this way 3 will pop out first, and then 2 and 1. Yeah, but for this example, we're gonna first, yeah, if there's a node from the left side, always from the left side, starting from the root node, from this node, we're gonna always put it inside the stack. So inside of the stack, it will be a 1. Yeah. Now, there's nothing we can put it inside because there's only one node. What we should do, if there's nothing, we need to pop this out because from the left side, we are sure there's nothing. The order is in-order traversal. So we're gonna take out this root node. So this means we're gonna put this 1 inside our result array. So if this is the result array, yeah, and this is the stack. So currently the stack, while you pop out 1, it becomes empty. Yeah, and the result is currently 1. Now what we should do? Yeah, we should still check from the right side because we are not sure if there's a node at the right side or not. Yeah, so we're gonna put the right side node inside our stack. So we're gonna take this 2. We are not take this stack yet, but we will take the root node as 2. Yeah, beginning the root node is ported to 1. Now the root node ported to a none because here from the left side is none. Yeah, but while we pop out from this one from the stack becomes empty. But from the right side there's another node. So here we're gonna take out this node and assign the root to this node 2. So currently the root is from node 2. So we're gonna take this 2 and 3 inside of the stack. Yeah, because at the left side there's still another 3. So currently 2 and 3 will be inside of the stack. So from the left there's nothing. We're gonna pop out 1 by 1. So inside of the result array from the beginning it is 1. Now we're gonna pop out this 3. Yeah. Why we pop out this 3? So we're gonna continue to pop out because we are sure from the left side there's nothing. Yeah. Why we pop out 3, and here we're gonna pop out this 2, because from the left side is nothing. Then we will go to the midpoint. We're gonna pop out this 2, 3 popped out, and 2 popped out, and 2 will be inside the result. And then we're gonna check from the right side of this 2. So for this node 2, there's nothing inside, it is a none. So we're gonna stop our iterative function and just to return this result will be 1, 3, and 2. So the principle is easier. It is just a linear. So it's gonna be like this line check. And then while we go to this node, this will be the root node. It will be like this. So each of the stack, it will always be like from the left side, it will be an arrow like this. Yeah, and then we're gonna put everything from the stack into the result. So it will be 1, 3, and 2. Now let's try to write the iterative solution. So as I explained, we're gonna need a stack and result. From beginning, it will be an empty array. So we need to check if the stack exists or not. From the beginning, the stack is not exist, but if the root exists, we can do something. So we're gonna check this root node. Yeah, so while root exists, we can put it inside the stack. So we're gonna put all the left side inside of the stack first. Yeah, so the root should equal to root dot left. So if there's nothing to put it inside, what are we gonna do? We're gonna pop out first. Yeah, so how can we pop out first? So we can use a node should equal to the stack dot pop, and then result can put the value, this node dot value, inside of the result. Yeah, while we pop out 1, we should always check the right side first. Yeah, inside of this example, while we pop out this 3, for example, 2 and 3 inside of the stack, while we pop out this 3 node, we should always check if there's a right node or not. Yeah, we are not continue to check 2. If it is not exist from the right, yeah, so we're gonna check this 2, because the in-order traversal, it will be from the left side and the node, and then from the right side. So we have to always check from the right side. Yeah, so if it is exist, we're gonna always check the left side first. If it is exist, we're gonna always check the left side like this. Yeah, so this is why we have to put the root node as the node dot right. Yeah, so if the node dot right is none, so from here the root is none, we're gonna not try to do the iterative function like this, but we're gonna check the next node. So the node would be stack dot pop. Yeah, so like this example. So if for 3 from the right there's none, so we're gonna check 2. So for 2 there's none, and from this point we're gonna stop the iterative function, because from this point the root is none and the stack is also empty, because the root dot none right is none at this point at here. Yeah. Now let me return the result and try to submit it to check if it works. Yes, as you can see, it works, and iterative function is a little bit faster than the recursive function, and this is also easy to understand because recursive calls also takes more time than the stack, pop, or append. Yeah, and the time complexity for the stack is also O(n), but here introduce the actual memory, so the space complexity for the stack solution will also be O(n). Yeah, because this is not balanced. If it is a linear for the space complexity, it will be O(n). But for the time complexity, no matter which ways, it will always be O(n). Yeah, no matter it is balanced or not. Yeah, no matter iterative or recursive, it will always be O(n). But for the iterative solution, if it is a balanced tree, the space complexity will be log n, or the recursive way, like the in-order traversal, the space complexity will also be O log n if it is the balanced tree. Otherwise, it will still be On. So for the big O solution, for the time and space, it will always be On. Thank you for watching. See you next